Before moving to the next thermodynamic term, enthalpy, let us see a numerical to find out how we can find out the work done whenever it is given in the form of a numerical. The numerical is the 2 liter of an ideal gas expands from a volume of 2 liters to 10 liters against a constant pressure of 5 atm. Find the work done. So this pressure is external pressure. We will take it as external pressure. We know W is equal to P external delta V. This is the formula. And since the gas is expanding, we know that it is the work done which is by the system, by the gas, so it will be negative. Now P external we know is 5 atm, and the volume change delta V is 10 minus 2, so it's 8 liters. So it is minus 5 into 8, so it's minus 40 liter atmosphere. So this is the work done when the gas expands from 2 to 10 liters against a pressure of 5 atm. But we remember we can also change this unit from liter atmosphere to joules, and for this we need to know 1 liter atmosphere is equal to 101.3 joules. So if we multiply it by 101.3 joules, we'll get the answer of 4052 joules. So this is the amount of actually work done when this gas expands.